Assalamualaikum warahmatullahi wabarakatuh. Today, we are going to present about X-ray. Introduction to X-ray. Well, X-ray are high-energy electromagnetic photons discovered by Wilhelm Röntgen in 1895 when he observed that a fluorescent screen glowed despite heavy shielding and produced a bone syrup of his hand. This groundbreaking discovery, made in his first lab, allowed him to image the bone of his wife's hands, revolutionizing medicine and earning him the first Nobel Prize in Physics in 1901. Their ability to pass through matter and generate contrast based on differential observation quickly made them a powerful imaging tool. Since the early film-based radiographs, the technology has progressed to digital radiography, computed tomography or CT scan, mammography, fluoroscopy, and phase contrast tomography, driven by advances in detector materials, photon counting sensor, and artificial intelligence assisted reconstruction. Benefit and very important in our daily life. For example, in healthcare, radiographic imaging enables rapid diagnosis of fractures, infection, and tumors, while CT and PET provide three-dimensional views that guide surgical planning and treatment monitoring. This is very important to us because not everything in surgical can be seen in naked eyes. We also need X-ray to see something beyond our eyes. For example, like something inside a muscle, or inside a lung, or inside the skin. Other than that, X-ray also important in public safety. Airport and cargo scanners use X-ray to detect weapons, explosives, and contraband, protecting travelers and supply chains without disrupting commerce. It's very important to protect our country from any terrorist act. It also is very important because we doesn't need to open any cargo to check them. So it also will not. So even this does not disrupting commons. The third is industry. Non-destructive testing reveal internal defects in critical components such as aircraft, fuselage, or pipelines, preventing catastrophic failure and extending product lifespan. For example, like if you want to detect any leaking or something, we can't just open it. For example, in aircraft, we also can open aircraft, but does not. But it also we can see a whole plane. So we need to use X-ray to detect a defect. Also, other than that, pipelines. Pipelines can be buried under a few dozen meter inside the dirt, inside a road or something. And we can also just dig and to just detect the leaking, we can use X-ray to detect them. First is food security. Inline X-ray inspection remove foreign objects from processed food, reducing recalls and safeguarding consumer health. It's very important to detect any foreign object in our food before they come to our table. Fits the first importance in scientific discovery. High-resolution X-ray microscopy and tomography uncover cellular architecture, material microstructure, and geological formation at nanometer scales, driving innovation in medicine, material science, and environmental studies. By using X-ray, we can detect something important in architecture. For example, like we can detect old monument that may be buried under the sand or something, or can detect a bone of dinosaur inside rock or something. Scientific instrumentation concept that underlie in X-ray technology. There are few concepts that underlie in X-ray technology. One of it is photon counting detector. It counts each incoming X-ray photon and record its energy, enabling through spectral multi-energy imaging. It's important to improve contrast, reduce dose, and allows material specific decomposition, such as separating calcium from iodine in CT scan. Second concept is direct conversion sensor. Semiconductor materials such as silicon convert X-ray photons directly into electrical charge, avoiding accidental intermediate. It's important because it provides higher quantum efficiency and finer spatial resolution than indirect accidental camera design. The third concept is spectral dual energy imaging. It requires two or more images at different X-ray energies and mathematically separates the contribution of different tissue type of material. It enhances diagnostic specificity, such as detecting gout crystal, and improves security screening by distinguish organic from inorganic substance.
So let's talk about where it's used. So the application of X-rays are used a lot in hospitals, but it's not limited to just that. There's also a use in construction to view cracks that may form in foundations or stress points that may show. There are many real-world applications that will be used, but that is in the next slide. As for now, it is the most common place to be used is hospitals. How does it work? So X-rays use high energy electromagnetic waves that penetrate through the materials or whatever object. It doesn't necessarily have to be humans, as we said before, that it doesn't need to be used in hospitals, or not to say it doesn't need, but it is not only limited to hospitals. So these wavelengths, these electromagnetic waves, have short wavelengths. This allows them to penetrate things. And so these wavelengths are usually at a length of 0.1 to 10 nanometers. So how these work, how do we see the images? So each material absorbs different amount of rays, and so this causes the different kind of colors. So usually X-rays would be blue and white. So the background would be blue, maybe. It depends on the material that was being used or is being printed out on the image. So it's usually everything that is absorbed, it is white. And so that is the cause of different amount of rays that are being absorbed into the material and the image being made because of that. So that's how X-rays work. So let's look at the real world usages. So in hospitals, they use it to scan people's bodies, people who have injuries, people who have gotten into an accident, to kind of identify the cause or what is wrong with the body, whether it is a fractured bone, whether there is something inside them. X-rays are used for that. Mainly, the various machines that are used are X-rays, CT scans, and MRIs. So all of that use waves. So generally all X-rays would use waves. The other one would be airport customs. They use X-rays to scan baggages for prohibited items, and it can even be used in archaeology. Just now we were talking about, and what I was using, I call it archaeology, is scanning the inside of artifacts, and this reduces the chance of breaking the artifact because they don't need to always be touching the artifact, they don't need to be cleaning it, they don't need to be seeing physically and alter a bit just to see where did this come from or what's inside of it. So X-rays can be used in multiple ways. So these are a few ways that real usages are used.
So let's move on to the next slide, which is benefits of X-ray machine. Actually, there are lots of benefits of X-ray machine, but first, it is fast and convenience. X-ray machine offer us rapid imaging capabilities that can be useful during emergency. X-ray These X-ray capabilities allow doctors or nurse to act quickly to save the patient. Second, security purpose. X-ray scanning is used widely in security field. X-ray machine is used to scan vehicles, cargo, or suspected objects. Usually, we see X-ray machine by securities in airport where it used to scanning objects before departure. Third one, unexpected finds. X-ray can sometimes show us a feature or pathology that is different from the initial reason for the imaging. For example, infection in the bone, gas, or fluid in areas where there should be none, or some types of tumor. The last one is non-destructive testing. X-ray scanning does not harm the object being inspected. This non-destructive testing allow X-ray to image the internal structure of material and component, revealing flaws like cracks or something unusual without harming the object. And the other benefits like non-invasive guidance and internal and external measurement. Okay, challenges of X-ray machine. First, software issues. X-ray machine is heavily rely on software for imaging and processing. Software glitch can possibly lead to bad image output, including incorrect brightness and contrast levels, or even complete image corruption. Second, radiation safety. This is because X-ray are the ionizing radiation that can potentially increase the risk of developing cancer. It is possible to develop cancer later in life when exposed to X-ray. Big challenge to minimizing patient and operator get exposed to radiation, so that we can reduce the percentage for patient and operator to get the cancer. Third one, for the last one, is high cost. X-ray are sold at very high prices because of the equipment used in them. Repairing an X-ray machine also costs a lot of money. So next, future development and innovations. This future development is considered important to simplify the treatment process for communities inside and outside of rural areas. So first, image resolution. Enhance image resolution for better view, enhance contrast and provide clearer image, allow from 2D into 3D image. This improvement is crucial for accurate diagnosis and treatment planning. Second, artificial intelligence, AI, and virtual realistic VR. X-ray machines equipped with advanced technology combined with AI will give doctors an advantage as it can help them make deeper and faster diagnosis. It will help doctors and nurses work faster and help more patients, such as emergency department and screening programs. And third, low radiating exposure. Make it safer for workers and patients. Reduce the number of patients due to radiation. With advanced technology, it isn't impossible to create an innovation to dose reduction in medical or industrial uses. This innovation in dose reduction are key to achieving these goals. The last one is portable X-ray machines. X-ray machine that allows doctor and nurses coming to treat in suburban areas. With the combination of advancement in technology and X-ray machines, the way has been opened for the creation of portable X-ray devices. It is a very clever and useful innovation. This machine can be widely used in areas far from technology or resource-limited areas, where access to advanced medical imaging is often limited.
Conclusion. X-ray technology remains a cornerstone of modern imaging, offering rapid, non-invasive visualization of internal structures across a wide range of fields. In tomography, provide essential diagnostic information that guides treatment, planning, and improves patient outcomes. Beyond healthcare, X-ray systems enhance public safety through airport and cargo screening, support industrial quality control via non-destructive testing, and enable scientific discovery by revealing micro and nanoscale in materials and biological specimens. Other than that, photon counting detectors
direct conversion sensors, and spectral imaging drive improvements in image quality, dose reduction, and material discrimination. Imaging trends, including artificial intelligence assisted in construction, portable units for remote settings, and integration with virtual reality platforms, promise to expand accessibility and diagnostic precision while addressing safety and cost challenges. Overall, the versatility, speed, and evolving sophistication of X-ray systems ensure their enduring impact on healthcare, security, industry, and research, reinforcing their role as an indispensable tool for observing the unseen.